Last week at iDug 2018 in Philadelphia, I learned a tidbit of information I was immediately able to come back to work and apply, and that is the concept of DB2 backup statistics. I had been struggling with a production level backup that seemed to be slow for its size. I wasn't sure if it was my imagination or if there was actually a problem going on. But then I learned about statistics. This is a DB2 environment setting that was default as of 10.1 Fixpack 2. And once it was in play, it started writing any information about the backup and what it was doing in your error log. So you could go mine that information and figure out, well, do I have an IO problem, or am I running into an issue with my buffers or compression? What exactly is it doing at what time, and where is it spending the bulk of that time? So I came home, applied it, and gathered my own statistics, and I'm going to show you what I learned so you can apply it to your own environment and see, could your backups be improved? Could you make them run a little bit faster? Once a backup completes, statistics on what happened are written to the DB2 diag log. Don't be alarmed, this doesn't mean anything was wrong because it's written to the DB2 error log. It's just that's where this information is recorded. There's a lot of information here that can help you troubleshoot why you may be slow in your backup. So let's go through a couple of the different areas. The first part, the top piece, is the buffer manager, and this is statistics based around the read phase of the backup, where the MC, the media controller, is based around the write phase of the backup. Now, one thing you want to notice is the number of BMs. It's based off of the number of table spaces. This does not mean you have taken a table space level backup. This just is how the backup is attacking its work. And so it's breaking things down here by the number of table spaces you have. The total is the total time in seconds for each part of the backup within that table space, where I/O is going to cover the time it takes to write to disk. If you're starting to run into a bottleneck at the disk level, you would probably see pressure here. Time spent compression will not always be visible here unless you are compressing your backup with the compress switch in the backup command. It's kind of interesting to do because it'll also show you in the far right how much data is compressed that wasn't compressed before. So you can see what lift you're getting and if it's a benefit to compress. If you didn't see my previous episode, you may want to take a look at it because I talked around scenarios about when you want to compress or don't want to compress, when you want to use DB2 and its compression library or gzip and its compression library. So it'll give you a guide on what you should or should not do. The message queue is different for the read side and the write side. In the read side, it's telling you how much time is spent waiting for an empty buffer so it can write the information it needs, where the write side is waiting for that buffer to completely fill before it goes and writes it out to disk. The wait queue at a very high level could be considered as the time waiting on a process to complete. So you could see here in my example that most of the table spaces seem to be waiting on the very first table space because of the time it spends in compression. In this specific example, this is what's slowing me down. It's not so much a disk bottleneck, it's the time spent in compression. So we've had a chance to look at our backup statistics and we may have an idea of where the problem is. So what are the possible solutions? First, I'm going to recommend that you read the article I have linked in the description written by Dale McGinnis. It's going to go into a lot more detail and give you some more starting points to take a look at. But the possible solutions could be narrowed down to roughly these 3 points. First, distribute your tables into your table spaces evenly. You want to avoid skew. This is what's hamstringing me. If you noticed in the previous slide, my BM00 is the table space where I am wasting a lot of time because of compression. So the other table spaces aren't being worked on. It's basically waiting for that first table space to complete. That's where my problem lies. The other areas you want to check is your util heap size. One interesting piece of information I learned from iDug this year is that the util heap size was basically set in a default way back in the OS 2 days. Many of you don't even know what OS 2 is, which should give you a good impression about how old that setting is. So you're going to want to bump that way up to see if it gives you some lift. The last piece that you want to take a look at is adjusting the number of target sessions. This is basically saying write to multiple files at one time. Now, what confuses people is they're going to see their backups end in .001, .002, .003, three separate files, and they're like, well, are these three separate backups, or how are they used? Just because you have multiple files doesn't mean there are multiple backups. There are actually three files that will be used to restore the backup of that single database. It allows you to write more in parallel. Bad vendor database design. That's what got me. We obviously accepted all the defaults and placed all of our tables in one table space, causing a lot of uneven skew. So I have a lot of work ahead of me. I need to redistribute those tables across the table spaces to see if I can get a little bit more parallelism, to get things working together at one time. What about you? What do your statistics say about your database backups? Let me know in the comment section below. I'd be interested in hearing. And as always, if you got anything out of this video, please subscribe so you're updated when new videos come out. Take care, and I'll see you in the next episode.